height or length and height. So that we have seen here. If you'll see the 1D means in the sense it is a one dimensional. So one dimension means either L will be there or B will be there or H will be there in 1D. If you even will see the 0 dimension figures also. 0 dimension figures means in that it will not have the length or breadth or height. Okay, so if you see the example of 0 dimension figures means any particular any points, pin points will be there, no, that type of points we can consider as a 0 dimension figures. And if you see the 1 dimension figure means we can take any one thread or hair of your hair. So it will have, if you put that one like this, it will have the whatever length will be there. If you put it in the straight on the board, what will have, it will have the height, but it will not have the breadth. And the breadth, if it have the breadth also, it will be very little bit in nanometers it will have. So that type of whatever the figures are there, those are called as a 1D. And if you see the 2D means which figures have both length, breadth or height, and also length and height. Okay, so and even you know that in 2D we have the, when you take the perpendicular of two planes, we'll get the two axes. That is here x axis will be there and this is the y axis you will have. Okay, so the figures whatever you will have, that you will draw in these two axes, and whatever the axis, this is the direction of this one is the positive one, and whatever it will have in the opposite direction, that axis will have the negative axis, and we will denote it with the help of the dash. So this is negative and this is negative. So whatever the figures we have drawn here, either the triangle or the line or the circle or whatever it is there, that you have seen in the 2D, and they will have only the two axes and x and y axis. And even we have seen what are the coordinates. If you'll see any point P on this plane, if it is, you'll have the coordinates as x comma y. That is the two coordinates will be there in the 2D. If any point is there, and whatever the figures we have seen in 2D, that is in the plane we have seen. So plane means any surface in which we can exist, the points will be there. So that part is called as a plane. So in that surface we have seen the figures having only the two axes, x and y axis, and having the two dimensions, any two dimensions. Okay, so that is about the 2D. And if we'll go to the 3D means to represent whatever the, like this two perpendicular two planes will take, no, if we'll take another one plane which is perpendicular to these two axes, then we'll get the figure in the 3D as like this. Okay, we'll get three axes. So this is the x axis and this is y axis and this is the z axis, and the meeting points of these perpendicular lines is called as the origin, and it is represented as 0, 0, 0. Okay, so and whatever the point is present in this plane, that point will have the coordinates as x comma y comma z. Okay, so whatever the point is present in this, it will be having the coordinates as x comma y comma z, and whatever the here points are there and the what axis are there means x y z. So these three axes will be there. And one more thing is, if in 2D these two axes are divided into 4 quadrants, 1, 2 and 3 and 4 quadrants. You have studied in it. Okay, 4 quadrants. And whereas in the 3D it is divided into 8 octants. Okay, so it is divided into octants, and even first quadrant, second quadrant, third quadrant and fourth quadrant, these all you will have the positive, 1 positive, 1 negative, 1 negative, 1 positive, negative. You have seen the what are the signs of the even quadrants present in 1, 2, 3, 4. Similarly, whatever the 8 octants are there, 8 octants will have 8 different XYZ values. That means in first octant you will have all positive, and in next octant one x will be positive and other will be negative, like that it will be there. So that part is given in your textbook in 8 octants. What are the signs of the given coordinates? So it is given in the page number 5. So if you see the octant here, 8 octants are given. So in that x, y and z coordinate, what are the signs are there? It is given. So, okay, the 3 coordinate planes, this and even planes are called as xy plane. From the xy, yz and zx, these are the planes. From these planes, we have got the figure, 3-dimensional figure. So the 3 coordinate planes x, y, z, zx divide the space into 8 equal parts, and each part is called as one octant. And like this, you will get the 8 octants. And what are the signs of that one? That is given here. And for this one, the direction, if you have like this, so the signs also you have to remember. This is the x direction is there, no? So you will have here positive, and here whatever you are getting the x dash, it is the negative sign will be there. And for even y also, you will have here negative y dash. This is the negative sign. And for z also, you will have z dash here, and this is the negative sign. Okay. So whatever the opposite direction, the rays you are getting, those you will get as a negative sign, and the positive direction wherever you're getting, those you will get as a positive sign. So you can see those in the textbook, it is given rectangular Cartesian coordinate system. It is in the 4th page number. And after that, and today in 3D introduction, in 3-dimensional geometry, I am telling we'll go almost all the view of the 4 blocks today and tomorrow. Whatever we have the 2 classes, we'll see whatever the important questions are there in each and every block. That is a 4 blocks. We'll see what are the questions you are able to get for the examination as for the 5 marks or as the 10 marks. So what are the 5 marks questions and what are the 10 marks questions, we'll see. And while going through the view of all the topics in this textbook, I'll tell which type of questions you are getting for 5 marks and 10 marks. And even you, if you have textbook, compulsory open textbook and round up whatever the questions I am telling. And you know already only 6 classes are there for the class elective. So 2 questions almost, 2 classes almost they will go for the introduction of that. Means we may not cover all the blocks 1, 2, 3, 4. I hope so. We may cover first block and half block of the second block. We may complete in these classes. Whatever the 3rd and 4th block are there. So if you know the almost the view of all the topics, what are the topics there in the 3D, at least you can do by yourself in your, if you have the free time. So try to solve all the problems. So if I will give the overview of all the units and whatever the block importance are there, which formulas and which type of questions you will get for the examination, try to round off them and try to practice them. Okay. So that I am giving today as the introduction of the 3D geometry. So the introduction of first 3D is already you know about 2D. So just you are comparing the 2D with the 3D. Here one more axis will be there, Z axis. Through that we are getting all the formulas. So in 3D you will have many number of formulas will be there. If you know in 2D also you have seen distance between the 2 points, length of the perpendicular, parallel line, straight lines, equation of a straight line, equation of a plane, and like this different topics will be there. Okay, first unit almost you will have about the points, and that is a distance between the 2 points will be there. And also in this Cartesian coordinates is there, and direction cosines and direction ratio. That is the first unit. Second unit is about the plane we have. Third unit is about the bisectors of the angles between the 2 planes. And second block is about the straight lines. So in straight lines, you will have straight line equation. What is the equation of a straight line? From the straight line, we have to find here skew lines will be there, and shortest line segment between the 2 skew lines. And in this only you have the show that the 2 lines are coplanar, or show that the 2 lines are intersecting each other and find the point of intersection. So these 2 are about the first and second block that you have already done in the 2D. But the third and fourth block are they are related about to the 3D. That is, we have about the sphere, and also fourth block we have the cone and cylinder. Sphere is about the almost it will be just like a circle, but here the equation of the sphere will be there. How to find the equation of the sphere? That is the somewhat questions you will have. So each and every block compulsory 2 5 marks and 2 10 marks questions you will get. Okay. So now if you'll go about this one, page number 6, you have observations are there. The x coordinate of every point on YZ plane is 0. So this, you will have the coordinates as if it is a XY plane. XY means Z equals to 0, means X equals to Y equals to Z equals to 0. YZ means here X is 0, Y is Z. Like this, you'll have the coordinates. Here X and Y 0 and Z you'll have. Like this, you'll have the coordinates. Okay. So that is given in the observation 6th page number you have. So these are all the objective type of questions. Okay. And the next second one also in the observation, and third one also observation, it is the important. And if you see the distance of the point P x1 x comma y comma z from the origin in space is given by. So you have seen the point in 2D if two coordinates are there. So P is any point. See, like this will have P x1 y1 and Q if you have x2 comma y2. So the distance between these two is PQ is equals to under root of x2 minus x1 whole square plus y2 minus y1 whole square. This you have seen in the 2D. In 3D, what we'll have, you will have the here the points will be 3, no? So you will get here Z2. So what is the distance? The distance is Z2 minus Z1 whole square. So like this, the simple, whatever the question is you there, you may get it for the objective type of questions, multiple choice or anywhere you'll get. So two coordinates will be given. From that you will have to find what is the coordinate, what is the distance between these two, P and Q. So it is equals to, you have to remember this formula. So here in 6th page number, it is given the distance of the point. One point P is there, X, Y, Z is there, and another point is the origin. Origin one, you will have 0, 0, 0. So when you find the distance between origin and any point, you will get x minus 0 whole square plus y minus 0 whole square plus z minus 0 whole square. So you'll get under root of x square plus y square plus z square. This is a simple one you'll get for 1 marks in the multiple choice. So like that only, when 1 point and 2 points are given, with the help of this formula, you have to find the distance between the 2 points. Okay. So that formula you have in the page number 8. Theorem is there now, 1.3.1. So round up whatever I am telling. Next is, if you'll see the 9th page number, note is there given, note in the down it is there, no? The perpendicular distances of a point P x comma y comma z form the coordinate axis x, y, z or under root of, if it is a coordinate axis x means you'll get the perpendicular distance as under root of y square plus x square. So this is also important. So this also, it is a objective type of question. Okay. And next we have the concept of the collinear points. So the collinear points means if you'll see the any straight line. In the straight line, if the points, whatever straight line, if you have the points 2 or more or even 3 or more, whatever the points are there, which they lie in the straight line. So that type of points are called as a collinear points. If 3 or more points lie on the same line, they are said to be collinear points. Okay. So whatever the line will be there, if you have the points in that. So like this, any straight line is there. So in this you have the points more than 3 also you may have. If they lie on the same line, then such type of lines are called as collinear points. Okay. So in this also you will have one problem which you'll get for the 5 marks question. 3 points will be given. A, B, C, you can take any points, and if you'll find the distance between those two, if you think A, here see 3 points are there. So here some coordinates will be given, 3 coordinates. If you find A, B, B, C or A, C. Okay. Sometimes you will get relation like this, A, B plus B, C equals to A, C. Or A, B equals to some quotient we will get here into AC. So if you get any of these relations, then we call A, B, C as a collinear points. Means there is a relation between the points A, B, C. You're getting AB plus BC is equals to AC. This relation, or AB is equals to some quotient of AC, or AB is equals to some quotient of BC, like this. If you'll get any such sort of relation, then we call A, B, C points as a collinear points. So this is one 5 marks question you will get on the collinear points. You can see the example as 1.3.3. And even some questions you will get like, show that the points, 3 points are given. You have to see whether the 3 points are forming a isosceles right angle triangle. Isosceles right angle triangle means 2 sides of the triangle will be same and third one will be different one. Okay. And if it is a equilateral triangle means 3 sides of the triangle you will get the same values. Okay. And if it is a square means whatever the 4 sides you are getting. So if you will get the same 4 sides has the same value, then you can tell the given points are forming a square. Okay. And next we can see the midpoint of a line. So when a line is there and it is dividing like this, 2 points are there. Next, we have seen the in 2D also midpoint we have seen. If P, Q are 2 and it is dividing as, if you take AB, you take here P, it is dividing in the mid of the point, and here M, it is dividing in M is to N ratio. We have the line segment that is, it is A and B are the end points of that one. It is dividing at the point P in the ratio M is to N. Whenever M is to N, it is called as a midpoint if the ratio of M and N is equal. If the both are equal, then we call it as a midpoint of the line. Okay. So, and even in 2D, here you will have the 2 coordinates x1, y1, here x2, y2. So midpoint is equals to, formula is x1 plus x2 by 2 and y1 plus y2 by 2. Okay. So if it is a 3D, what will have, z1 will be there and here z2 will be there and here one more z1 plus z2 by 2. So this is the midpoint. Midpoint formula also, it is an objective type of question. And one more is, if a line segment is there and here AB we have, okay, one line is there which is having the AB and it may divided in the ratio of lambda is to 1 or M is to N, but they both are not equal. They may have different values. So when such type of like this is there, you have the coordinates or finding the lambda value. What will have formulas you have in textbook, it is in the 12th page number you have. Hence the coordinates of the point R which divides the line joining the points will be in the form of mx2 plus nx1 by m plus 1, my2 plus ny1 by m plus 1. It is a page number 12. Above you have, no? So whenever it is divided like this, we can take mx2 plus nx1 by m plus n, my2 plus ny1 by m plus n, mz2 plus nz1 by m plus n. Okay. So we'll get the coordinates of the point R as like this. So in this only we have the concept of whenever it is the coordinates of the points which divides a line joining the points x1, y1, z1 and x2, y2, z2 in the ratio m is to n. One internally will be there, another one will be externally. This is the internal formula. So plus sign will be there whenever it is external. You will have here minus and minus in the numerator and denominator. Instead of the plus sign, you will have the negative sign. So here page number 13, whatever the formula is there, this internally and externally, this is also important for solving the problems. On this, you will get one problem for 5 marks. Okay, the questions will be like this. Example, it is given. Find the coordinates of the point which divides the line joining the points in the ratio 2:3. So already points are given and even ratio is also given. Just to substitute the in this formula, if you substitute, you will get the coordinates of this one. X coordinate, Y coordinate, Z coordinate, you will get. Okay. So in some case, what will they will give is they'll give the points and the ratio will be not given in the question. We have to find the ratio of that one. Okay. So that question will be like this. 13th question, it is there, no? Find the ratio in which YZ plane divides divides a line joining P and Q. So we have to find the ratio here. One hint it is given that it is ratio is having the line joining is having in the YZ plane. In YZ plane means what? X is equals to 0 in YZ. In YZ plane, X coordinate will be 0. So when you substitute that one in the formula, you take the X coordinate is equals to 0, then you will get the lambda value. So from the, if you will get the lambda value, you can equate that one, then you will get the ratio. Okay. So this type of problem you will get for the 5 marks question in unit 1. Next, if you will go to the next question, you have about the angle between two non-intersecting lines. Two non-intersecting line means they are called as a skew lines. Skew lines means like this. They are not parallel and they are not intersecting. So such type of lines are called as skew lines. Your definition is also given in the, so which are not intersecting and which are not parallel, neither parallel nor intersecting. Such type of lines are called as skew lines. And next we have the concept of the direction cosines and direction ratios. This concept is the important one. Why? Because if you know what are direction cosines and what are direction ratios, you can solve up to 2 blocks. First and second block, we have the concept of this one only. So for this one, first you will see the direction cosines. In shortcut, I am writing this one. This is the direction cosines. So if you'll see the axis like this, X, Y, and Z we have. Through this one line we are taking. So like this you have. This is P and this is Q. And one more line which is parallel to this one. This is AB. It is in the direction like this. So then, so this X and Y, whatever the planes are there, it is making the angle alpha. And next it is this P line and this Y, whatever it is there, it is making beta. And next, whatever it is there, it is making gamma. So these, whatever the axes are there, with the help of that, if we'll take, the definition is given here, if alpha comma beta comma gamma be the angles which any directed line. So this directed line is AB. With AB line, these 3 axes, they are making the 3 angles. Those angles are alpha, beta, gamma with the positive directions. We know already these are the positive directions. If we'll take the opposite direction, they are the negative directions. Okay. With the positive directions of X, Y, Z axis respectively. So these, with the help of this one line, these 3 axes are making the angles alpha, beta, gamma. Okay. So you can take like this gamma. So then cos alpha, cos beta, and cos gamma. These 3 are called as the direction cosines of those. Okay. So then cos alpha, cos beta, cos gamma are called the direction cosines of the given line. So whatever this line is there, for this line, with the help of this line, these 3 axes are making 3 angles. So when they are making the 3 angles, you will get the these three whatever the values you are getting, cos alpha, cos beta, cos gamma. Okay. These 3 whatever values are this, those values are called as the direction cosines of the 3 axes, X, Y, Z axis. Okay. So with the help of this line, they are making 3 angles, and with that you have the formula now. That is, if it is a cos theta means you will have the adjacent side by hypotenuse. With the help of that, if you will find the values, you will get the cos alpha, cos beta, cos gamma. So these are called as the direction cosines of the given line AB in positive direction. Okay. And these whatever direction cosines are there, they are represented as L comma M comma N. Okay. So if the direction is BA, if you take it in the opposite direction, then you will get here the values as minus L comma minus M comma minus N, or minus cos alpha, minus cos beta, or minus cos gamma. So these are the opposite sign. So these are the negative direction cosines and these are the positive direction cosines. Okay. So we usually denote the cos alpha, cos beta, cos gamma as L comma M comma N. So that is, if you have any doubt, you can see the definition given in the textbook. And same here, next page, page number 6, you have here, if the direction cosines of a directed line AB are L comma M comma N. So direction cosines of the directed line BA will have minus L comma minus M comma minus N. Okay. So how proof is also given in your textbook, how you got negative values and how you got the positive values. So no need of the proof, just you remind what are the direction cosines in AB direction and BA direction. Okay. After that, you have corollary, is there no second one, direction cosines of x-axis and y-axis and z-axis value. These are very important while solving the problems. You have to remember x-axis will have 1 0 0 as direction cosines, and y-axis will have 0 1 0, and z-axis as 0 comma 0 comma 1. So these are direction cosines of the axes. Okay. So remember these values, even for the objective you will get, and also for solving the problems you will get. So these are called direction cosines, and they are, you remember these L comma M comma N. They are represented as L comma M comma N. And from this only, in the down, you will see one result. You will get these relations. These are very important. X equals to LR. Okay. This is one result, and second one is L square plus M square plus N square equals to 1. So these two are very important for solving the problems, and even they may ask for even objective type also. This whatever relation is there, L square plus M square plus N square equals to 1, for solving the problems we'll use in many problems. So from this concept of the direction cosines, you will get these two results. So these two results are very important in solving the problems. So try to remember that one, how we got that result. That proof is also there in your textbook, but proof will be not asked for the examination. Just for the objective type or for problems it is used. And in 18th page number, if you see the example 1.6.3, it is a 5 marks question you will get for the examination. Here two angles will be given in the question. That is, a line makes angles 45 degrees and 60 degrees with the positive axis. If negative axis is mentioned in the question, means you have to take the negative angles, that is minus 45 degrees and minus 60 degrees. But it is mentioned as the positive, so plus and plus sign with respect of x and y. So x and y means two angles are given. Third angle we have to find the angle that it makes with the positive axis of z axis. That means, so third means z means you will have the gamma, no? So we have to find gamma. Already alpha angle is given and beta angle is given. And we know that L is equals to cos alpha, M is equals to cos beta, N is equals to cos gamma. So these two angles are given. So third angle we have to find. So L, M, and N values also we know. So if you substitute this L, M, N values in this relation, you will get the third angle. So that whatever proof is there, solution in the textbook, you try to see that one. Like that only example, other examples are there. Check your progress are there, no? 6th question you can see same example. Next we have the main important topic, that is the direction ratios. So direction ratios and direction cosines, they are interrelated to each other. So if you know the concept of the direction cosines, then we can know that relation of direction ratios. Okay. So direction ratios and direction cosines are proportional to each other. Okay. So here direction ratios of a line means there will be 3 numbers. Okay. Those 3 numbers we can take as A comma B comma C. These 3 numbers which are proportional to direction cosines of a line are called the direction ratios of the line. Okay. 3 numbers A comma B comma C. These 3 numbers are proportional to the direction cosines. What are the direction cosines? L comma M comma N. So that means L by A is equals to M by B equals to N by C. So whenever they are proportional to the direction ratios, those 3 numbers, they are called as the direction ratios of the line. So these When they are writing like this proportional, you are equating it to one constant number. Then you will get the relation as L is equals to AK, M is equals to BK, and N is equals to CK. Okay. So A, B, C, these are the direction ratios, and they are proportional to the direction cosines. Okay. So we'll get the here the relation will get LMN value are there. No, we know just now we have seen one result, L square plus M square plus N square equals to 1. Substitute LMN values here. So what you'll get AK whole square plus BK whole square plus CK equals to 1. So if we'll take out K square outside, you'll get A square plus B square plus C square equals to 1. And what you'll get K square is equals to 1 by A square plus B square plus C square. And K is equals to plus or minus 1 by A square plus B square plus C square. Okay. So we got the K value. Substitute this K value here. If you substitute here K value, so what are the direction cosines? When you are comparing the direction cosines and one direction ratios, you will get the direction cosine values as like this. L is equals to plus or minus. Here if you substitute this value, it is A by under root of A square plus B square plus C square. And M will be plus or minus B by under root of this one. I am writing sigma A square. If you expand that one, you will get the same one. N is equals to plus or minus C by under root of sigma A square. Okay. So then these L, M, N are called as the direction cosines of the given line. Okay. So that is the relation between direction cosines and direction ratios. Okay. So this A, B, C are direction ratios. Here, whatever the values you are getting, L, M, N, these are called as the direction cosines of the line. So if you remember this one, it's useful for solving the many problems. Even second block also, you will have the concept of this one. So this whole, whatever the proof is there, that is given in the page number 90. Whatever the relation you are getting are the direction cosines of a line, where the same sign, either positive or negative, is to be taken throughout. Why? Because positive, if it is negative means negative sign will come up, and down you will get a positive sign. Okay. So on that you have the example 1.6.5. If the whatever the points are given, 1 comma minus 2 comma minus 2 are direction ratios, means these are A, B, C values. Then find the direction cosines of the line. When A, B, C are known, we have to find LMN values. So if you substitute in this formula, you will get easily the LMN values. So this such type of problem will be asked for 5 marks question, or else you will get for the objective type of question also. Okay. Next we have the next concept is about, so even page number 22 also you have an example problem is there. Find the direction cosine of the line joining the points P and Q. So this is also, if you know, even check your progress also, 8th question it is there. So these are the problems which you may get for the 5 marks question. Next, the main important topic is page number 25. You have 1.8 angle between two lines having direction cosines. So this formula is useful for solving the problems. So when two direction cosines are given like this, L1 comma M1 comma N1 and L2 comma M2 comma N2. So direction cosines are given, two direction cosines. Then the angle between two lines having direction cosines. So that angle usually will take it as cos theta is equals to L1 into L2 plus M1 into M2 plus N1 into N2. Okay. This is the angle between the two lines having the direction cosines as these two. So this one, remember. Okay. This formula is important for solving the problems. And next you have, if instead of these direction cosines, if we have direction ratios, that is A1, B1, C1, A2, B2, C2. If you have, then you will have the formula in page number 27. You have here cos theta is equals to, this formula is very important. Okay, this is also A1 into A2 plus B1 into B2 plus C1 into C2 by under root of A1 square plus B1 square plus C1 square into A2 square plus B2 square plus C2 square. This is the very important one. For solving the problems, we will use this cos theta. Okay. Same formula. Whenever direction cosines are there, we will use this one. Whenever direction ratios are there, this one. Okay. So usually for solving many problems, you will use this formula only. So cos theta is there, no? Sometimes we'll use, only in rare cases, we'll use the sin theta formula or tan theta formula. So regularly you use the only cos theta. And here you have the conditions. These conditions are important. 27 page number only. Corollary is there, no? Third one. Conditions for perpendicularity and parallelism. If two given lines are perpendicular, then theta, perpendicular means they will make the angle 90 degrees. No? Okay. So they, whenever two lines are perpendicular means they'll make the angle 90 degrees. That is theta will be pi by 2. And we know that cos pi by 2 is 0. So therefore this denominator value will be there. Only numerator value will be there. That is numerator value is equals to 0. Okay. So that is whenever perpendicular. Whenever parallel means both lines are parallel means theta value is 0. Then you will get the sin theta you will get here. So then you will get the some relation. Why? Because cos theta value you will get as 1. So we'll go whenever two lines are parallel, we'll go for the sin theta. So in sin theta, you will get some relation whenever two lines are parallel. Next, we have the concept in the 28 page number. If 4 points are given, find the angle between the lines RS and PQ. You have to find the direction ratios of two points, and whatever the direction ratios you are getting with the help of the direction ratio in this formula, if you substitute, you will get the angle between those two lines. Okay. So main 29 page number, very important and is a regularly asking question. It is the foot of the perpendicular. Okay. This is the, even if you'll see, if you have idea about the 2D, in that also you have seen the foot of the perpendicular will be there. This is the regularly asking question, which you will get for the 5 marks. You know, this is called as a foot of the perpendicular. If AB is any point, here point P will be there. It is divided like this. This is called as a foot of the perpendicular. It is divided in the ratio lambda is to 1. So some A value will be given, and here this is called as a foot of the perpendicular. Okay. So coordinates of how the question will be, find the coordinates of the foot of the perpendicular from point A. Here in the question it is given from A to BC. So this is A and this is BC. Okay. So from A to BC, we have to find the coordinates of the foot of the perpendicular. That means we have to find the point D. So first take it in the ratio lambda is to 1. We have seen the formula now. So with the help of that formula, we can find the D value, whatever the procedure is there to see in the textbook. But it is the regular question you will get in the examination. Okay. Next year, 1 point up till here, whatever we have seen, those all are the 5 marks question. Now, whatever I am telling the questions, these are the 10 marks questions. Okay. So next 1.9.4, you have the exercise problem is there. That is a line makes angles alpha, beta, gamma, delta with the help of the diagonals of a cube. Prove that cos square alpha, cos square beta plus cos square gamma plus cos square delta is equals to 4/3. So this is the very important one, and this is the very easy theorem. Okay, as a you can call it as a even theorem also. Sometimes it is asked as a statement will be given, and whatever the proof of this one is there, you can have to do the proof of this one. So you can you know that it is of a cube. No, cube means how it will be like this. And if you'll see the axis, these are the axes. So this is the X, this is the Y, this is the Z, and with the it is forming the 4 diagonals like this, 1 diagonal, 2 diagonal, and one more will be like this, another will be like this. Okay, it will form the 4 diagonals, and which will have 1, 2, 3. See here, 1, 2, 3, 4, 5, 6, 7, and one more here. So it will have the 8 coordinates will be there. 1, 2, 3, 4, 5, 6, 7, 8. 8 coordinates will be there, means 8 points will be there, different points. So in the same direction, positive direction, you will have the positive values. In the negative direction, they will have the negative values. With the help of these all values and with the 4 diagonals, you can find the problem here. Okay. So, and it is making the 4 angles. 4 diagonals are making the 4 angles. Those angles are alpha, beta, gamma, delta. Okay. So with the help of that, you have to find that square of those 4 angles is equals to 4 by 3. Okay. If we have the time, we'll try to solve this one. And on this, whatever the relation is there, you have even 5 marks problem is also there on this one. Okay. So next 10 marks question is 1.9.5. So this is also very important. It is regularly asked. These two are very regular questions. And prove that the 2 lines whose direction cosines are given. From that, you have to see if those 2 direction cosines are perpendicular, what is the condition, and if they are parallel, what is the condition. Okay, this is also the 10 marks question. And next, if we go to the 33 page number, 1.9.6 is there. This is also one of the proof and regularly asking 10 marks question. Show that the angles between the 4 diagonals of a rectangular paralleloid are cos inverse of this one, a comma b being the edges of the paralleloid. So this is just as a theorem you have. Whatever the 1.9.4 is there, similar to that one only. But here the whatever proof is there, somewhat slight different is there. So these 3 are the important questions for the 10 marks. And as you know, you will have the 3 series will be there, A series and B series and C series. 3 set of question papers will be given. If you hope up till now 4 semesters you have written, you might have the idea about these 3 series. So 3, whatever I have the told the 3 10 marks question, each one series you will get one question. Okay. So set unit 1, 1 10 marks question, and unit 3, 1 10 marks question. Okay. So I am telling clearly with the questions you are getting. So try to practice these all problems. Next, if we'll go to the 38 page number, whatever the 4th question is there and 1st question, these 2 are the 5 marks questions, 1 and 4. Okay, this is about the unit 1. Clearly, I have explained about the unit 1. Okay, try to whatever the example problems are there or exercise problems are, check your progress. From this only you are getting all the questions. Rarely you will get from the model examination questions. So no need of doing all the solution. All the solutions are given in the textbook only. The thing is you have to practice the problems. Okay. If you have any doubt, you can ask while seeing these problems. Okay. Even I have told what are the formulas are also there. That formulas also you can see. Okay. Next, if you go to the unit 2, that is the plane and various forms of the equation of a plane. Okay. So you know plane means it is a surface. You have the definition also in page number 41. A surface is called a plane surface or a plane if all the points of a straight line joining any 2 points on the surface lie it. So we can take this, whatever blackboard is there, this is one of the plane. Okay. So if you draw any straight line, what are the present in that straight line, they also lie in this surface. So such type of surface is called as a plane surface. So we can draw in plane any type of figures. Okay, 2-dimensional figures we can draw in the plane. Okay. So in we have here what is the equation of the plane. So 2 forms of the equations are there in plane. One is the general form of the equation of the plane and another one is the normal form of the equation of the plane. These 2 are important. If you know what are the forms of the plane, with the help of that you can solve the problems. Okay. So next we have about the plane. In that, one is general. Next one is the normal form. Okay. So general form will be like this: ax plus by plus cz Okay, ax plus by plus cz plus de equals to 0. And if you see the normal form of the equation of the plane here, okay, normal form of equation of plane, this also same. It will be lx plus my plus nz equals to p. Okay, this is called as the normal form of the equation of the plane. These, you have to know these two equations. These two are very important. Okay, general form and normal form. And one problem will be there, in which general form equation of a plane is converted into normal form of the equation of the plane. That means you can convert this into this form also. Okay, and but you remember these two are what are the forms of the equation of the plane. Okay, so here whatever the a b c are there in this, with the help of, if any one point is given, then we can find equation of any plane passing through the point. So any point is passing through that, so we can find the equation, this equation with the help of this formula, a into x minus x1 plus b into y minus y1 plus c into z minus z1 equals to 0. So if any point is passing through the plane, then we can find the equation of the plane, x1 y1 z1. So this is important for solving the problem. This formula you have to remember for finding the equation of the plane when one point is given. Okay, so this you have in the page number 43. This formula is there. Next we have in page number 45, transformation to the normal form. So from the general form, you are converting it into normal form. One relation you will get. The relation is very important. We have already seen, no, the that is a by l is equals to b by m equals to c by n equals to, if you take these two relation, what you'll get, a by l is equals to b by m is equals to c by n equals to d by minus d by p. If it will go that side, minus d, already p is on the positive. So like this, if you take the relation and if you substitute them, then you will get the relation as l equals to plus or minus same one, l square plus m square plus n square. If you substitute there, you will get the relation. With the help of that, we can convert general form into normal form. So one question will be asked for 5 marks for conversion of general form to normal form. And in the note, if you'll see 45 page number, second one is there, no, it is very important one. From the equation 3 of 2.2.3, the perpendicular distance from the origin to the plane. So any plane, this equation is there. Then to find the perpendicular distance from origin. Origin means here 0, 0, 0. From origin to this plane, if he is asking the perpendicular distance, means here x coordinate is 0, y coordinate is 0, z coordinate is 0. When you substitute here, what will get? These all, it will become 0. Only remainder is d. So d by under root of a square plus b square plus c square. So we'll get it as plus or minus. Why this one means, whatever the quotients are there for this one, those squares. We have seen just cos theta formula, no? A1 into A2 plus B1 into B2 plus C1 into C2 by whatever it is there under root of A square plus that one. If you substitute these two into multiplication, this part it will become 0, remainder is only d. So d by under root of this one. 0 square means root of 0, that is 0, no? So only this part you will get. So this is the perpendicular distance of the origin to the plane. Okay, this formula is also important. And with the help of that, next you have the example in 45 page number only. Find the direction cosines of the normal to the plane. Okay, this is also important. Next 46 page number only, an example is given. The perpendicular distance from the origin to the plane. One plane is given. So you will get only d by under root of that one. Next 46 page number only, example is there, no, reduce the equation of the plane to the normal form. This is the regularly asking question for 5 marks. This one, and in your check your progress, you have 2 problems are there. These 2 problems also converting the general form of equation of a plane to normal form of the equation. So this is one 5 marks in second unit. Okay. Next we have the concept of angle between two planes. Angle between two planes means here two planes in normal form. General form we have, no? This one, two planes will be like this: a1x plus b1y plus c1z. Next, a2x plus b2y plus. So these two are the equation of planes. So the angle between these two planes will be a into a1, a1 into a2 plus b1 into b2 plus, okay, divided by under root of a1 square plus b1 square plus c1 square by a2 square plus b2 square plus c2 square. This is cos theta equals to plus or minus. Okay. This formula you have to remember. When two planes are given, find the angle between those two planes. Okay. Next, you have the condition of perpendicularity and parallel. When they are parallel and when they are perpendicular, what is the condition? To this formula, you have one example problem is there. This is also they may get asked in even fill in the blanks or multiple choice, or else 5 marks problem also will get for this problem. So check your progress. Third question is there, no? Find the angle between the two planes. Just substitute the values here and you will find it's enough. You will get the 5 marks for this one. This is one concept in this. And after this, next page number 54, you have one corollary is there, no? The length of the perpendicular from the point to the plane is, formula is there. This is the important one. This will be useful for solving the problems. For this formula, you have the example in 55 page number. Example above is there, no? The length of the perpendicular of the point from the plane. Okay. So same one you have in your check your progress also. And 55 only distance between two parallel planes. That formula is also there here. Okay. Distance between the two parallel lines example. So these all formulas are important and problems. So next 57 page number 2.6.1 worked out exercise is there. No, this is also one of the 5 marks question. And 59 page number 2.6.3, 2.6.2. These two are also important. These two are 5 marks questions. Means rarely you will get those. So whatever, only one 5 marks question you will get in the second unit. So no 10 marks question in the second unit. Next, if we'll go to the third unit, it is the, we'll complete the third unit and we'll wind up. Okay. Bisectors of the angles between two planes and two sides of a plane. Here, whatever the bisectors problem is there, this concept you will get compulsory for 10 marks question. So 9A question will be from first unit, 9B question will be from third unit. So that problem will be on bisectors of the planes. So here same two plane equations will be given. So for the two plane equations, we have to find the formulas are there. See, if you'll see 67 page number, bisectors of the angles between two planes. So two planes will be given. For them, the perpendicular from P, just now we have seen the formula, no? That formula you have to substitute here. So one plane divided by under root of its quotient are there, no? A, B, C, you have to do the square of them. It is equals to plus or minus second plane equation by that one. And after simplifying that, two planes we are there, no? This A1 x plus b1 y plus c1 z plus d1. This is one plane equation. Next one a2x plus b2y plus c2z plus d2 equals to 0. This is one plane and this is second plane. If you substitute in the formula, bisectors formula, then you will get here plus or minus sign of this one and this one. Okay. After simplifying these two, one you have to do the addition, next one you have to do the subtraction. So you will get another 3 and 4. That is another two plane equations you will get. Means 1 and 2 are the given planes, and from this relation we got two more planes. So if you will do 1 and 3, 1 and third equation, or 2 and 4 equation, you will get the angle here, angle between these two planes and angle between these two planes. Okay, so if the angle is less than 45 degrees or less than 1, we call it as acute angle. Here if you'll get greater than 45 degrees or greater than 1, we call it as the obtuse angle. So the question will be like this: find the angle of bisectors of the given two planes and find the equation. Which equation of the plane is making the acute angle or obtuse angle, he will ask in the question. So this is the 10 marks question. First you have to substitute in this formula, then we'll get two equations. From the two equations you have to find, if from 1 and 3 or 2 and 4, you will find the angle. So which angle is making acute angle, which equation is making the obtuse angle. So that is the problem. See, if you'll see page number 69, 3.2.1, example problem is given. So if you know this procedure, any problem given on this, you can solve. Okay. So this is the important one, 3.2.1. This is a regularly asking question. If you want more example, you can take 3.2.2 and even check your progress is there, 72 page number. This is also regularly asking questions. These whatever 3 problems are there, if you make the practice of that one, you can easily score 10 marks. So if you do all the procedure correctly, you will get the full marks of that is a 10 marks. And next concept in this is in third unit, it is the two sides of a plane. So two sides of a plane means here one plane equation will be given and 2 points will be given. So if you substitute those 2 points in the plane equation, if you substitute first point in that plane equation, you will get one value. If it is a positive value, then it will be greater than 0. If you substitute another point, if you will get the positive value, means if you will get the two signs same for one point. If you think A and here one plane is there, if you substitute this value, if you are getting greater than 0, and one more point is there, if you substitute in the same plane and also you are getting greater than 0. If you substitute A point, you are getting greater than 0, B point, you are getting greater than 0, means they are on the same side. Okay. So if you substitute A point on the plane, if you are getting one is less than 0 and another one is greater than 0, then we call it as the plane lie on the opposite side. Okay. Same side means here the sign should be same. Opposite side means one will be less than 0, one will be greater than 0. So on this topic, you have the example problems are there here. Show that the origin and the point lie on the opposite side of the plane, or they lie on the same side of the plane. So the example problems are given in the 73 page number 1, 2, and even you can see the check your progress also examples are there. So these two topics, bisectors and also two sides of a plane, these two are important for the examination point of view. So these two are important. After that, one more is 83 page number. Find the angle of the triangle whose vertices are the points. When three vertices are given, there is a 3 vertices points are given in the question. He is asking to find the area of the triangle. So for that, you have some formulas are there. With the help of that, we can find the area of the triangle when 3 vertices are given. Okay. So that also given example problem is there in your textbook. Next, another topic is volume of tetrahedron. So volume of the tetrahedron also, this is also one of the 5 marks question you will get. That formula is also there, and also one example problem is also there in your textbook. So these are the 4 topics you have in the textbook. And if you go to the 94 page number model examination questions, first and second question, these two are the 10 marks. Same bisectors, whatever we have seen in topic. So on that only other questions from these, any example problem or check your progress or MEQ questions, any 3 questions for the 3 series, you will get the 10 marks questions. Okay. This is about the block 1. Next tomorrow we'll see the block 2 about the straight lines, and also the block 3 and 4. Just slight introduction. We'll see about second and third block and fourth block. Next class on the 28th and 29th, some important problems on whatever we have seen the blocks, we'll go through them. Okay. maximum how many number of questions we can cover, we can see. Okay, so already I have discussed about the first block important questions. So try to start practicing. Why? Because you may get the examination schedule. So try to practice and start the doing 3D. 3D is the very easy one. Why? Because all the solutions are there in your textbook only. And if you remember the formulas, it's enough for solving the problems. Okay, we'll meet tomorrow.